Good morning, all of you. So today I will discuss oscillation. So I'm writing here oscillation. See, in oscillation, first we will tell about periodic motion, right? So first I am writing here what is the definition of periodic motion. So what is periodic motion? Means it will repeat its path after regular interval, right here. It will repeat its path after a regular interval of time. What is the meaning of this? Suppose I have this string of length L here, one point mass of mass M, that is point mass. So if I am telling, suppose this is now moving along this circular path. So suppose this is point A, so it will move now. It is moving now. So after a fixed time, it will come back at its initial point. Suppose let us assume that point is that time, suppose t. So it will go, and after one complete time period t, it will come once again here. So that is called periodic motion. Once again example, suppose I have a that is a sun, right? And now earth is revolving around sun, means that is elliptical path. So this earth has how many time period? 1 year. After 1 year, it will come back toward its initial point. So that motion is also called periodic motion. So in our daily life, everyday life, there are many examples of periodic motion, right? So I am telling about suppose one ant, you have seen ant. So suppose here that is wall, and ant is moving up and going down. Once again moving up and going down. That is also example of periodic motion, right? So next I will tell about oscillation. What is oscillation? So I am telling about oscillation, right? That is called actually oscillatory motion. Now I am checking a video is going on. Okay, yes, quality good. So oscillatory motion. So here right now, to and fro motion is called oscillatory motion. What is this now? I am telling, to and fro motion is called oscillatory motion. See, suppose I have once again I will take that example of a simple pendulum. So see here now, that is one mass m%, and that is a string length L%, and here I have fixed, right? So suppose I just here how many forces? Sir, in a string tension force, that is tension force, and downward that gravitation means mg force. So this is now in a rest, like that is called equilibrium. I am taking, suppose I want to apply force, and due to that force it is going now that like that, and now it will come back. Okay, suppose I applied force, it is going down like that. Okay, that is my that suppose angle theta, and that point is A, that point is B. So like I am telling here example, suppose that is one string, and that is this cap, you can assume mass. Okay, that is fine. Now I have applied force, so due to that force it is going down. Now due to restoring force, I will tell what is the meaning of restoring. So I applied force, it is going. Now once again it will come, and further it will go here also. Got my point? So that is called to and fro motion. So this is called to, and that is called here now fro. Okay, to fro, to fro, to fro. One thing remember all of you, if this angle is theta, so this fro angle also will be theta. Okay, means same displacement. Okay, so now I will tell, that is actually to and fro motion, that is called oscillation. Okay, So now I will write two definition. First definition is means mean position, and second about restoring force, and third I will write about extreme position. So write what is a mean position. Okay. What is a mean position? You know, if you will solve a question in oscillation, so many times you will realize that means mean position word will present there, or that means oscillatory motion word, or that restoring force word will be present there. Okay. So I will write here that mean position. What is mean position? The position at which restoring force become zero. The position at which restoring force will become zero. So here restoring force I will tell. So that is called mean position. Now you write about restoring force. I am writing a star, that is also star. Okay, that is a restoring force. What is a restoring force? So right now, right, the force acting on particle, the force acting on particle which tends to bring the particle toward its initial position called restoring force. So here I will take just example of this now oscillation, so that you can get clarity. Means what is that mean position, what is that restoring force. See, suppose I took example of that spring, and that is a block system. That mass of this block is m, and here now that is a hinged point, just hinged or fixed, and that is a frictionless surface, right? That is here a frictionless surface. Okay, frictionless surface. Okay. So you know this point here, that point is called because that is called mean position. Why mean position? Because in this condition our that spring length is in natural length position. Okay, so that is called mean position. Got my point? So here what is restoring force? Zero, sir. At this point, what is restoring force? Here I am writing that restoring force like that equals to zero. Okay, restoring force zero. Now I applied force. So what will happen here now? If I will apply forces, suppose I will apply some forces, so it will now like that, it will go here now. So you know, suppose I applied force, so that spring will expand.